Have you ever wondered what lies beyond the three dimensions we perceive in our daily lives? We're so accustomed to living in a world defined by length, width, and height, but what if there's more to it? Let's start from the beginning. Consider a point. It has no dimensions, it's zero-dimensional. Now if we stretch that point, we get a line, which is one-dimensional, having only length. Stretch this line perpendicular to itself and you get a square, which is two-dimensional with length and width. Now if we pull this square perpendicular to its plane, we get a cube, a three-dimensional object with length, width, and height. But what if we could stretch that cube in another direction, one that's not length, width, or height? What would that look like? That's where the concept of a fourth dimension comes in. Indeed, the concept of a fourth dimension can be mind-boggling. But don't worry, we're here to delve into this enigma together. Imagine you are a two-dimensional being living in a flat world like a character in a drawing. Your world is flat, without height, just length and width. Now picture a three-dimensional object, say a sphere, passing through your world. What would you see? You'd see a point that gradually grows into a circle, reaches a maximum size, then shrinks back to a point and disappears. But what you wouldn't understand is that this changing circle is actually a constant sphere moving through your plane. In a similar way, we as three-dimensional beings might perceive objects from the fourth dimension. We see and experience them in three dimensions, yet they possess an extra dimension, one that we cannot perceive directly. We see only parts of them, snapshots if you will, that fit into our three-dimensional perspective. So if we struggle to imagine the fourth dimension, it's not due to its non-existence, but our limited perspective. Often, people refer to time as the fourth dimension, but is that entirely correct? This question leads us into the fascinating world of space-time, a four-dimensional structure that blends space and time into a single continuum. Here, time indeed plays the role of the fourth dimension, yet it's not quite the same as a spatial fourth dimension, the concept we've been exploring so far. In the realm of physics, we often hear about the interplay between space and time. Objects move through space over time, and this movement can be plotted on a four-dimensional graph. But this doesn't mean we're dealing with a fourth spatial dimension. Instead, it's a temporal dimension, distinct from the three spatial dimensions we're familiar with. So, when we talk about a fourth dimension beyond our three-dimensional world, we're not necessarily referring to time. So while time is a type of fourth dimension, it's not the kind we're trying to visualize here. Let's recap what we've learned about the fourth dimension. We started by acknowledging the challenge of visualizing something beyond our three-dimensional perspective. It's like asking a flat, two-dimensional being to grasp the concept of a three-dimensional object. It's not impossible, just mind-bendingly difficult. This analogy helps us understand our own struggle to perceive a fourth spatial dimension. Then we delved into the intriguing distinction between time and a spatial fourth dimension. Time is often regarded as the fourth dimension because of how intrinsically it's tied to our universe. However, it's different from a spatial dimension, which would add an entirely new direction of movement. This journey into the fourth dimension has been a mental workout, a fascinating exploration beyond the limits of our everyday perception. So next time when you gaze at the stars, remember that there might be more than meets the eye. After all, the universe is full of mysteries waiting to be unraveled.